Hey yo, hey yo, hey yo, hey yo! It's Mr. G coming at you live for a video about systems of equations. And we're going to solve them by using the elimination method. So hopefully at this point you should know how to solve a system by graphing, and you should also know how to solve a system by using the substitution method. So this is method number 3. This is the elimination method. Sometimes this will be easier than substitution or graphing. Sometimes it won't be. It just depends on the system that we're looking at. So, when solving a system of equations by elimination, what we want to do, the main idea, is to add the equations together in order to cancel out a variable. Okay, so if I look at these systems right here, I have x plus y equals 7, I have 2x minus y equals 2. Now, if I wanted to do the substitution method, what I could do is, of course, I could solve for one of my variables here, and then I could do a substitution. That's fine. Okay, and that will still work. But what I could also do, actually I'm going to move this down here. What I could also do is I can add my equations together. Okay, and we add by combining like terms, of course. Okay, and you can only add the left side of the equal sign with the left side, right side with the right side, so on and so forth. But I can do this by combining my like terms. And so when I add these together, 1x plus 2x, that is 3x, and I'm combining them to make just one equation right now. And the reason why I'm doing it is I want to cancel out a variable. And if I look at this, positive y and negative y cancel each other out. And so I'm left with just 3x equals 9. I have a simple one-step equation that I can solve by dividing by 3, and now I can figure out what my x is. And x equals 3. Now, again, just like with substitution, what I want to do is once you figure out what your x is, you need to take that and plug it back into either one of these equations. It doesn't matter which one you plug it into, but you need to plug in x so that you can figure out what your y is. Pick whichever equation you think is easiest. So I'll just do the top one, 3 plus y equals 7. So we can obviously write away that y is equal to 4. So my final solution to the system is 3, 4. And I'm all done. And I can plug both points back into my second equation just to make sure that it works and just to make sure I'm not missing anything. But that's it. So with a system, when you're solving by elimination, you just want to cancel out your variable. And you're going to do that by just adding the equations together. Okay, and when you add the equations together, the goal is to eliminate a variable. Now, let's say, though, that this was negative 2y. Now, if I combine these, am I going to cancel anything out? And the answer is no. So that means I got to manipulate the equations just a little bit in order to eliminate them, in order to eliminate a variable. And that's what we're going to look at right now. So, if you cannot cancel anything out by adding, then what you need to do is you need to multiply one of the equations. Doesn't matter which one. Multiply an equation so that you can cancel something out. So here's what I mean. If I look at these two equations right here, so my goal with elimination is to eliminate a variable when I add these two equations together. So if I add these two together, I'm just going to have x plus 2x, which is 3x. I'm going to have 3 plus 2, which is 5y equals 13. That doesn't help me. I can't solve an equation that has two different variables in it. I only have one equation. So what I want to do is I want to eliminate one of the variables so I can solve for another one. So if we look here, if I multiply this whole equation by 2, if I had a 2x here, then at least we have the same coefficient, which is good. But if we also look at it, if I want to combine these, I need one of these to be negative and one of these to be positive. So by looking at this, if I need this to be a negative 2, what I would then need to multiply this entire equation by is negative 2. But the big thing is that when we multiply the whole equation, we need to multiply every single piece inside that equation. So I need to multiply the x by negative 2, the 3y by negative 2, and I also need to multiply the 7 by negative 2. And again, I want to go back and look at where did I get negative 2 from. And this is just me doing a little bit of mental math and looking at what do I need in order to cancel these things out, in order to cancel a variable out. And if I look at the 3 and the 2, I can't multiply 3 by something right away. That's simple. I can multiply it by a fraction, and we don't want to do that to get to 2. And I can't multiply 2 by something to get to 3 in order to cancel something out unless it's a fraction as well. So those aren't going to really work very well. I could multiply both of my equations if I wanted to, but that seems like a lot of work. Now, if I look at this, though, I'm looking at how do I cancel out 1x and 2x? What can I multiply one of these by to get to the other? Well, I know I can multiply 1 by 2, and that would get me to 2, which would give me the same coefficient. But I'm also multiplying by a negative 2, and the reason why it's negative is we want to be able to add them together to cancel them out. Okay? So, and then we definitely have to have a negative and a positive to cancel out. So when I multiply this, I'm going to have negative 2x. I'm going to have negative 6y, and then I'm going to have negative 14. So this equation right here became this equation over here. So this is gone. Now I'm using this one. And now when I add these together, whoops, that's a negative. When I add these two equations together, my 2x and negative 2x are now going to cancel each other out. Okay, now I have positive 2y, negative 6y. That gives me negative 4y. I have 6 and negative 14. That gives me negative 8. Now I can just solve real quick for y, and I get y equals 2. And just like before, now that I have one of my values, I can take it, plug it back into an equation. Again, you get to choose which one you want to plug it into. I'm going to choose this top one here. I could use this first one here. I could use what I changed it to. I could use the second equation. It does not matter. This equation and this equation, these are the exact same thing. They're still going to give me the same values for x and y. Okay, and I could still use this equation as well. It does not matter which one I choose to plug it back into. I'm going to choose my original equation on top, and the reason why is because the x doesn't have a coefficient, so it's just less work for me to do. Again, I don't want to say I'm lazy, but I want to take the easiest route and do the least amount of work as I possibly have to. Okay, so I get x equals 1. So my final ordered pair is 1, 2. And I am done. All right. Now, oh, real quick, I got a math joke for you guys. What do you call best friends who have math class together? So what do you call best friends that have math class together? Algebros. All right, moving on. Now, we have one last one. I want you guys to try this one on your own first, see how you do. And then after that, we can then check, pause the video, see how you do, check afterwards, see if you got it right, and then we should be good to go. This will be the last example of the video, by the way. Okay, so hopefully you solved it. You should have, unless you cheated, and then you decided to not pause and try to solve it on your own. So what I notice right away when I combine these, if I were just to add these together right away, 8 plus 5 is 13, negative 2 plus negative 4 is negative 6. So I'm not canceling any of my variables out, so this will not work. I have to have the same coefficient for either my x's or my y's, and then I also have to have one be positive and one be negative. So right away when I look at 8 and 5, these don't look very easy to get to the same number. So if I look at 2 and 4 though, I know I can multiply 2 by 2 to get to 4. So that can give me the same coefficient, so that's good. So I know I have to multiply this whole thing by 2. But now I have to look at, do I want to multiply by positive 2 or do I want to multiply it by negative 2? Because again, we want to have opposite signs so that when we combine them, they cancel out. So again, we're looking for the same coefficient and we're looking for opposite signs. So because these are both negative, I want to multiply by negative because I want to make this a positive. Because if I make this a positive 4y, negative 4y will cancel each other out. So I'm going to multiply this entire equation by negative 2. So this is going to give me negative 16x, positive 4y, and that's going to be equal to positive 16. So this equation right here has changed into this equation. We didn't change anything because we multiplied both sides by negative 2. We're allowed to do that. That's okay. All right. So now I'm going to add my two equations together. So I have 17 plus 16 is 33. Negative 4y plus 4y, that cancels each other out. That's why we did it. And then 5x and negative 16x makes negative 11x. So negative 11x equals positive 33. So now I can just solve for my x to get negative 3. Pick an equation to plug it back into. Now, whichever one I pick, it doesn't look like it really matters. It looks like I'm going to have a little bit of work to do regardless. So again, it does not matter which one to plug it into. I'll just choose the first one just because that's seems to be the easiest way to do it. So it's 8 times negative 3 minus 2y equals negative 8. Negative 24 minus 2y equals negative 8. Let's see, let's add 24 to both sides. I'm going to have to go over here because I'm out of space. So I got negative 2y equals positive 16. So when I divide by negative 2, I get y equals negative 8. So my final ordered pair, negative 3 and negative 8, this would be my solution to the system. This is where the two lines intersect at the point negative 3, negative 8. And again, to check my work, I can plug that back in to the second equation, not the one that I solved it with. Let's plug it into the other one, the one that I haven't done work with it yet. And I could do a quick check of doing 5 times negative 3 minus 4 times negative 8. And should that equal 17? I hope so, because I get negative 15, positive 32. That does equal 17. I'm good to go. Rock and roll. We did it right. All right, and that's all I got for you. So systems, big idea is you want to have your variables cancel each other out when you add the two equations together, just so you can eliminate a variable and then solve for just one of them. And the way you do that is you make sure you have opposite signs and the same coefficient attached to one variable, and then you are good to go. All right, if you have any questions, please let me know. Good luck. Thank you for watching. Take care. See you guys later.